Hey, what's up, gang? I know some of you are really adamant about using prime notation because it is a lot cleaner. So we're going to look at chain rule with prime notation today. It's the same idea, but we had to learn it with d over dx just to understand why we need to multiply by the inner function. Today we're going to be looking at this and explaining exactly how we can think of when to use chain rule. So from last year, you might remember composition of functions. It's basically saying I have a big function f of x, which is composed of two inner functions. We'll say g of h of x. Okay? So let's define g and h of x. Maybe g of x is x squared, and maybe h of x is x plus 2. You know what, let's go with x to the power of 3 plus 2. Okay. So then what can we say? We can say, okay, well, a big f of x is going to be equal to this inside function h of x squared. Look at that. That is the basics of a composition function. It's just two functions put together. So when we take derivatives with the chain rule, we are dealing with functions that look like this, that are compositions of functions. When we say, okay, x squared, this is a single function. We're just squaring x. But when we look at something like this, we are doing two things to it. Well, we're doing multiple things to it. So what we need to do is apply the chain rule. In terms of prime notation, the way we think about it is, okay, we'll have an inner function, which is h of x, because it's on the inside here. Look, g of x is on the outside of h of x, so h of x is called the inner function. Let's write that out. Inner function. And g of x will be called the outer function. Okay? So when we say f of x is equal to g of h of x, then f primed of x, or the derivative of f of x, is going to be the derivative g primed of h of x times h primed of x. So the derivative of the outer function with respect to, this means with respect to the inner function, times the derivative of the inner function. This is exactly the same thing we learned with Leibniz, except it's in prime notation now. So whichever you prefer, yeah, it's up to you. It's personal preference. Let's work out an example problem using prime notation. So we'll use our definitions here. So we'll say, okay, what's the derivative of x squared, so x cubed, plus 2 to the power of 2? Okay. We'll call this f of x. I want you to find f primed of x here. So take a moment to pause the video and figure this out. Okay, I hope you had a chance to figure it out. Now, we're going to first define h and, oh, actually we've already done this here. We've done g of x and h of x. So this is what g of x and h of x are, and according to our definition of the chain rule, we need to take the derivative of g of x with respect to h of x. So we're taking the derivative of this whole thing, basically. So we're going to take 2. So you're going to just use power rule. 2 times x cubed plus 2 to the power of 1, right? That's what we're doing. We're taking the derivative of the whole thing with respect to the inner function, which is this. Remember that since we're taking the derivative of this whole thing with respect to the base, this is the base here. Because it is with respect to the base, we're allowed to use power rule like this. But don't forget, we need to multiply by the derivative of the inner function. The inner function is this, and I'm sure lots of you already know, this will be 3x squared. So, again, using the chain rule, we've differentiated a function. Just like that. We can get rid of the little 1 here, that's not necessary. That will be the derivative of our function, and of course, if you wanted to, you could take an extra step and write this as 6x squared times x cubed plus 2. Anyway, that's going to do it for prime notation on chain rule, and we'll work through a lot more examples because this is a really tough concept to get. See you in the next video.